Hello students, welcome to my class Chemistry Gurukul. In my previous video children, I had initiated the introductory part of chapter carbon and its compounds. So just moving on to the next topic, today we will discuss about allotropes, or you can say allotropy. It is a phenomena. It is very important in board exams. This topic is very important and questions are being asked every year. So focus on this topic today. It will take little bit time but very important topic, so we will explain. Now allotropes of carbon. What is the meaning of this word allotropes? Actually children, some of the elements, they have tendency to be present in different forms. Means chemically they are same but physical nature is different, means physically it will appear different. However, the chemical constituent of these compounds are same, means the element which is present inside it is similar. Okay, so we are talking about carbon here. So carbon is present in different allotropic forms like diamond and graphite. In your book these two compounds, these two structures are given about diamond and graphite. Apart from that, fluorines is also discussed, but most important points today we are going to discuss about diamond and graphite. So the definition is clear, I hope. I have written here, allotropic forms or allotropes are the different forms of the same element having different physical properties but almost similar chemical properties. And the phenomena of existence of allotropic forms of an element is called allotropy. Here you could see, you have to note this point, that is allotropy. It is a phenomena. Now as I told you that carbon exists in three crystalline allotropic forms, diamond, graphite and fluorines. We are going to discuss the first two topics today, that is diamond and graphite. I have drawn two structures here. I could explain you in well manner. I hope you will understand. You could see here in the structure children that one carbon is further attached to four other carbons here in this structure of diamond. That's why it is also known as the hardest substance which is present on the earth till now. So you could see here why it is hardest, because the structure is compact and it is bonded with the strong bonds to each other and there is no space left in between them. Okay, so it forms a crystalline structure and it is very hard. However, in case of graphite, here you could see that it is in the form of hexagonal structure like a benzene ring. About benzene you will study later on. But here you could see that three carbon atoms here are attached to the three carbon atoms on the other end and they are forming a layer like structures. Above this, below this, one more layer is there and further layers are present. So there is a gap between these two layers. Due to this gap, its nature is soft as compared to diamond. Okay children, I hope you have understood. If you are not able to understand, I will show you one 3D effect so that through this bond structure, I hope you can understand that this carbon atom is further attached to these four carbon atoms. You could see here, and similarly further this carbon atom will be attached with the other four carbon atoms. This carbon atom again attached with the other four carbon atoms, this also. So they form a compact structure children. That's why diamond has a hard nature. Okay, due to its internal bonding of carbon atoms. But this structure is not seen in case of graphite. That's why it is different from diamond. Now we will discuss some contradictory part in these two substances. Diamond has three-dimensional rigid structure as we have seen here. Graphite has layer structure. Could see here in the diagram. Next is diamond is the hardest substance known, however graphite is very soft. Diamond is a bad conductor of electricity, however graphite is good conductor of electricity. This point is somewhat little bit confusing to some of the students, but don't confuse, because as you have seen here, there is no gap between. So how the electrons will move? Electrons, they need some space to move. However, here in this case, some space is there, free space for the movement of electrons. That's why here you can see there is a space. Children, you might be seeing this graphite in your pencils. Okay, here in case of pencil, the lead part is made up of graphite, and you could be knowing about this. This is very soft. You can easily sharpen it with the sharpeners, and the layer forms are removed to sharpen it. Now moving on to the next part. Diamond has very high density, means it is denser as compared to graphite because of its structure. However, graphite is less dense than the diamond. Its density, you could write the digits I have written here. It is 3.514 gram per centimeter cube. However, graphite has 2.226 gram per centimeter cube than the diamond. Next is diamond is chemically unreactive. However, graphite is reactive. What does it mean here? It means that due to its internal structure, strong bonding, they generally do not react with any substance. However, graphite, they have a space between them. So that's why they are used in various purposes where they do reactions. However, they do not do as reactive reactions as you have studied, but they also take part or in that process. Suppose in batteries, graphite is used as an electrode, okay, because it can transmit, or it is a good conductor of electricity. So that's why it is used there. This is given in your video clip. I have sent you some of the uses of diamond as well as graphite. You know, children, diamond is also used for drilling, where you might have studied in your junior classes that whenever petroleum products or crude oil, they are being taken away from the deep you can say sea level, so there are some rocks are there to drill that rocks, hard substance. These diamonds are used. So this is as hard as you cannot imagine. These are very hard, and that's why they are used for drilling the rocks. Apart from that, this diamond is also used for cutting the glasses in different shapes. You might have seen different shaped glasses in window pans, or in big buildings, or you can say on different types of furnitures are made nowadays of glasses. So beautiful decorative items, they are being cutted with these diamonds. So certain uses I have sent you, you may note it down from there. Now coming on to the third allotropic form, that is the fluorines. Children, in 1985, this fluorine was this allotropic form of carbon was discovered, and it was named as Buckminster fluorine. Why? Because there was an American architect. The name has been derived from his name, and he had drawn the structure similar to the structure of fluorine. Fluorine has you can say 60 carbon atoms. It has the formula C60. You can note it down, C60. So how it is made up of? It is made up of some hexagons and some pentagons. Now what are these hexagons and pentagons? Hexagons means six-sided structures. As you could see here, this is six-sided structures. Penta means five-sided structures. Okay, so you might have seen football at your home, or in the movies, or in the on TV also. So football has the similar structure of fluorine, Buckminster fluorine. It has 20 hexagons and 12 pentagons. So you can calculate. So it will become say 60. So this is it, children, for today's topic. I hope you have understood it well. Thanks for watching.